So in parametric design, we learn how to create equations, how to create parameters, and how to apply them. Now, a little more advanced topic is creating laws, okay, which are basically functions that you can evaluate at different values of parameters and use those to create the coordinates for basically curves for which the equation follows a law, right? One of them that is quite common and used a lot is basically an involute curve, the curve that is used in a profile of a gear tooth. So that is a parametric curve, and the coordinates of xy points on the tooth profile are both function of a parameter t, which basically, if you go to our canvas under modules and go all the way down under tutorials and then look at this guy, says spoor gear tutorial, it shows you what kind of curve is an involute curve, right? So let me show you that first. So it involves a ton of parameters, and then these are the equations. So here is YZ plane instead of XY, it doesn't matter, but one of the coordinates is like a dimension times sine t minus t cosine t. The other one is the same dimension times cosine t plus t sine t. And as t changes from some number to some other, the points that you will get from y and z coordinate, the pair of y and z, will form for you this involute curve. Okay, so let me show you that. This curve here, from this point to this point, any point on it, the pair y and z follows those rules, those parameters, those laws that I showed you, right? Which was r base, correct? Times t minus sine t minus t cosine t, and then the other one is r base cosine t plus t sine t. And we evaluate these functions at a specific value of t to get a specific point y and z, then move t to another number and get another yz point and keep going, and then we connect all of this together using S-spline, and we get our curve, right? So for example, let's go through something simple. So one way to define a circle, let's go over a simple curve. One way to define a circle is using what? Using the equation of it. Let's say if it's centered at origin and the radius of the circle is r, then we know that any point on that circle if you call this point here on the circle x and y, and the radius of the circle is r, the equation of the circle is what? X squared plus y squared equal r squared, right? Fine. Now, we can draw a circle in CATIA, no problem. We can define ellipse, we can define other function. But now, let's say I want a kind of curve that does not exist in CATIA. Like what? So I cannot draw it using those sketcher commands, right? Like what? Like sine function. So if you have something like this, okay, so here y is sine of x. Well, how would you create this kind of curve in CATIA? Well, to do that, as I said, you define a parameter t, and then say x is equal to t, and then y is equal to sine of t. So if you plug in t equal x in the bottom equation, it's the same as what? Y equals sine of x. And then you change, let's say you go what? You go 3/4 cycles, right? So you come all the way down to here. So what is that point? This is 6 pi, right? So now you make sure that the t is anywhere between 0 to 6 pi. So you evaluate these two functions at different t values. Let's say one at 0, one at 0.1, 0.2, 0.3, all the way to 6 pi, which is a little more than 18, right? So you evaluate those two functions, those two laws at different points, and then what? Connect them all with spline, and then you get a very good approximation of the sine function depending on how many points you are using, right? Because all of those points follow y equals sine of x. So how do I do that, right? Or as I said, if you want to create a circle, so circle, since we have the tool for it, it doesn't make sense to create a log like that. But if you want to do so, then you can define the parameter t again and then say x is equal to what? R cosine of t, and y is what? R sine of t. And then change t, which is the angle here, anywhere between what? 0 to 2 pi. This will create for me a bunch of points on this circle, and if I connect them together, I can get a circle, right? But again, we don't need to go through all that pain because CATIA is doing that for me behind the scene. So what I want to do is something that I don't have in CATIA, like sine of t or so. So let me show you how to do that. So here, if we go to shape generative shape design, by the way, what I'm teaching you here is not limited to shape design. You could do it in Sketcher in general. So you could do it in Sketcher and then use it in part design, or do it for shape surface design or anything. So basically, this is a little more related to Sketcher here, but let's see how we do it. So if I go on this plane, and then even without going to that plane, let's first create our laws. So to create your laws, you don't need to go to any plane. So you go under the design table, and then you here see FOG, or law. So you click on the law and then give it the name. So I call this law for X. And then I OK that to get this window. And here it says you want a new parameter of type what? Since t is a real number in general, right? It's the angle here for me in radians, so I say it's of type real. And then here it says the name of it. I call it formal real 1, but if you don't like it, type whatever you want and enter. Then I want another parameter of type length, and I call this guy x, right? So I created two parameters, just like when you did equations, right, or formulas, x and t. And now here I say x is equal to t, which is a real number, times 10 mil. Remember that you need to make both sides of this equation or formula to have the same units, right? T is real, x is length. So if you want both of them to be of unit length, you have to convert them into what? Into the same thing. If you don't want it times 10, just make it times 1. Doesn't matter, okay? So here is just to make the points further away from each other, but that's fine. Let's say t times 1 mil. Okay, and apply that and okay. So now if you go under the tree and you activated the relations tab, now you can see this first function created called x. Then you can repeat that and create the function y. Okay, so here I call this y. And again, I say I want a real parameter and call that for me t, and then I want another one called y, and then here I say y is equal to sine of t. Now again, t is real, but it has to be in angles, right, in radians. So whatever t is, I multiply by 1 radian. So now it is going to be in radian. And now sine of a number has no units. So I multiplied by 1 mil to convert it into length. So look at all I'm doing here to make sure my units of the left and right hand side of the equation work. Right? Remember, t you define as a real number, but sine always takes a radian inside. So I multiplied by 1 radian, so sine would work. And then sine of a number is, sine of an angle is just a number. It has no units. So I multiply it by mil to convert it into length. And I get that. Now that I have it, I go to this plane, let's say, and I create a sketch. And here, when I click on the first point, you see this is the first point, right? And the coordinate of that is 0 and 0. Or if you don't want it even on the simple plane, okay, you can do it in 3D. You don't have to do it in 2D, okay? So let me show you. You don't, as I said, you are not limited to any sketch plane. So let's say instead of that 2D point command, I use the 3D point command. Just to force it to be on the XY plane, or let's say here, I want this guy, which is YZ plane, I force all of my X's to be what? 0. Or if I want it on XY plane, I force all of my Z's to be 0. So when I want to calculate X for the first point, I don't type the number, I say what? I right click and say edit formula, and here I evaluate this function at a t where is between t is between 0 to 6 pi or 2 pi or whatever. So I provide a value of t, a parameter t, and then evaluate both x and y of the point at that t value. Okay, so how do I evaluate? This is how, it's a command. You say relations under \x. So you see here, even this one is highlighted for you. Say, okay, this guy, I want this one, right? If you double click on it, it also brings that for you. So the name of that thing that you made is called relation \x. This is how you access it. And then you say dot evaluate. What is dot? You probably, if you know, CATIA is written in C. And when in C or Python we use dot, dot is to access an operator, right? A function for that relation. So this relation is a class variable, right? It's a class, and then it has some variables and it has some functions. And this evaluate is a function for the class relations. So you say evaluate that at what? At t equals 0, right? So basically you say set t equals 0, apply it to this function x equal t, and whatever number you get, then use that, right? So here you see it says, yeah, I have a typing error, okay? I have a spelling error. So you have to make sure when you do it, okay, you know what you're doing, because if you type in one letter incorrectly, then you're not going to get the final result that you expected. So here again, evaluate x, relations \x dot evaluate at 0. Okay, no error. Yes, okay, and you see that's 0. Then I right click for y and do the same thing. It is the function y dot evaluate at 0. So evaluate sine of t at t equal 0 and 0 and 0. So I get the first point 0. No big deal. But now let's say I want the same functions to be evaluated at let's say pi over 6, right? So I go here, and then again I say I want this function evaluate at pi over 6. And let's see if CATIA also recognizes pi as pi, just like MATLAB does, or we have to type in the number. Okay, so I leave it as pi over 6, 30 degrees. Let's see if CATIA recognizes that or not. So you see here, it says parameter pi cannot be used in this context. What are you talking about? Okay, I don't like what you said. Pi, I don't recognize pi the way you wrote it. Okay, so if you want, use 3.1415 or something. Okay, So it does not take pi the way that you just ask it to do. So evaluate at 3.1415 divided by 6. Now let's see if division by 6 is considered. Okay, yeah, that is fine. Then I want this one now. Again, evaluate at 3.1415 divided by 6. So sine of pi over 6. It should be okay. That looks a little bit suspect. It multiplies it by 1 radian, right? Oh, 0.02 inches, fine. The unit for y was in mils. This is converted into inches. Why? Because my default of units is in inches. If it was in mil, then I should have half a mil. Okay, so the reason it is this small number is because it's converting mil to inches at the same time. And then you keep going, right? So now you have 0.2, you have 0.1, and then keep creating points more and more and more, right? So let me do a few more for you. So again here, dot evaluate at 3.1415 divided by, let's say, 3 this time instead of 6, correct? You okay that, and then here, use it for y. So you get your third point. If I do zoom to fit and zoom in, you can see the points. And then I keep going, right? Let's just do a few more points. So this time I divided by, I did pi over 6, pi over 3. Now I have to add another pi over 6 to it, so it's going to be pi over 2. And then again here, pi over 2. So I get my fourth point, and now I need 120 degrees, which is 2, correct? It is 2 pi over 3. Then I need 150 degrees, which is basically 5 over 6 of pi. And one more point, which is pi itself. Okay, this guy here. So here I just calculated it between 0 to pi instead of 0 to 6 pi, and I get all these points. And now if I connect them using the 3D spline, correct? So all I need is to go and click on 3D spline, and then it says what points. All you need to do is to say point 1, 2, 3, 4, 5, 6, and 7. Okay, and now if you look at it from this direction, I guess we missed the point, didn't we? We missed the point, so we have point 3. Somehow this point is not used. Although it should have been used, but it was not really. So let me do it one more time, make sure what I'm doing. Here, 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 and here. Okay? So, again, that is interesting, although the point is there, but it is not passing it through the point for me, which is quite interesting. So if I remove this point, yeah, seems like it was selected twice or so. But now you see a rough sine function. The more points I evaluate, the better I would get, right? And then I can connect them and make my sine function. So, fine. Now, this is about creating laws, evaluating them for basically parametric curves. Another important thing, advanced thing that I want you to learn is geometric sets. So geometric sets are like folders where under the folder you can have all sorts of different components. Okay, so here, let's say I use like 100 points to define my SP-line, right? Now, if I use 100 points here to define this curve instead of 7 points, then you see on my tree, I'm gonna have a very, very long tree, right? Because there are just 100 points on it. And this tree is gonna be super long. And if I want to access anything, basically at the bottom of the tree or middle of the tree, I have to keep scrolling until I get there. So when I have a bunch of things and I don't want all of them to individually appear on the tree, but I want to put all of them under the same folder and have one single icon on the tree for all of them instead of individuals, I use a geometric set. So geometric set is a folder under which you can put curves, points, surfaces, and so on. You don't need to have all of the components inside the geometric set to be the same type. It's like a folder in your computer, right? You can save a music file, put the music file under this folder, a video file, a Microsoft Word, and a text file, and so on and so forth. So that's the same thing here. So we say insert for me a geometric set, and I call it SP-line points. Right, and I insert it, and then I hold shift and select all of these points, and then I cut them and I paste them inside this geometric set. Okay, so now if I close this, they're showing themselves under the tree as individual items, right? All of them are grouped inside this folder. Now here you see I am getting an error, so I cut and paste all the points under the geometric set folder, but now the SP-line is not showing itself anymore, and it looks like I'm getting an error, and the reason is those points that I used to define this SP-line are now basically removed from their location, so this SP-line cannot find the points it needs to define itself. Okay, so maybe it's a good idea that now I have these points under this folder if I do the SP-line definition afterwards, so that it knows it borrowed this point from inside this folder, not from under the tree. Then it knows where to find these points, and it should not give you an error, right? So when you move the reference points or reference entities for another entity from one folder to another, so this under this gear body, under this part gear body, the point it's considered like the C drive, for example. And then under the C drive, you have a bunch of folders. Each one can have its own name. Each one can be a separate geometric set. So if one file is referring to these points under the tree, but now it says, okay, I'm using these points under the tree. Now I cannot find those points under the tree anymore. Somebody moved them. And so that entity, which is here, the spline, gets confused. I cannot find the points I need anymore. Where are they? And so it gives you the error. But here, I first copied those points in this folder, into this folder, and then I define my spline. So spline knows that the point it needs is what? They're all inside this folder. If I go ahead again here and cut these and paste them back under the gear of part body, I would get error again because I'm changing the location of the required points for the spline. So don't try to do that. Okay, one last thing I wanted you to know is creating a local, or we call a secondary axis system or coordinate system. So many times in real life, we use secondary or tertiary or so many other coordinate frames, okay? It's not that we always use one coordinate frame in our problems or in real life. You might wonder where. So the picture that I added to the slides for you is this robotic arm that is holding a 3D scanner at the end effector. This is the base of the robot, which is fixed to the ground, and it is scanning this sheet metal. And now, actually, when this 3D scanner measures the XYZ location of a point on, or so many points on this sheet metal, those XYZs are with respect to which coordinate frame? Of course, with respect to the coordinate frame that is attached to the device, because they are measured by the device, right? Not directly by the original fixed coordinate frame of the robots, which is, we call this base coordinate, we call this the end effector coordinate frame. So here you see I'm specifying these points with respect to a secondary coordinate frame. That's the same thing in CATIA. In CATIA, we always have the original coordinate frames, right? This original XYZ, but we can always create a secondary coordinate frame where the location of the origin and the direction of the axes are different from the original one, and define the location of the new points with respect to the secondary coordinate frame. So let me show you how to create it and how to use that. So here, as I said, when I click on a point and want to specify the coordinate of the point, it says what? If you'll see here, it says the axis system is default or absolute. So I am defining my X, Y, and Z points, these coordinates, with respect to what? With respect to the absolute XYZ system, right? No problem. But as I said, you can create a secondary coordinate frame. Where is that? If you see the tools toolbar, it's on the tools toolbar, which is this guy here, or you can go under insert and say I want to insert an axis system. Or as I said, you can find it here next to the update commands. So say I want to create a new frame, and then it says, okay, where would you want to put it? So you have to have a point or create a point. Let's say I want to put the new origin here. Then it says, do you want your x-axis to be default, which means parallel to the original x? Or maybe you can rotate it. Say, no, well, actually, I want my new x to be, let's see if it allows me to choose the y-axis. I don't know, but I can try it. Not really, but it says, okay, create a line for me. It says, sure, I would create a line. It says, from which 2 points? I say, my first point is going to be 0, 0, 0 for the line defining the x-axis. Then my second point, I would choose a point on the y-axis. So like that. So now, if you see, my new x-axis is parallel to y actually. Says, what is your y? So I make my y to be parallel to the old z, or I can give it angle even if I want to. So here, I go ahead and again, create a line for that, and using 2 endpoints, again, I choose my origin to be 0, 0, and the second point of it to be a point on the z-axis. Right, so now this is my new y-axis. And then, of course, z is going to be default. It's computed, right, because it's a right-handed system. So once you know x and y, z is perpendicular to both. Okay? And then this gonna be called axis 1. So here. So now if you can see, if I just hide these guys because I don't need them anymore, look at this. This is a secondary coordinate frame where it has a separate origin and the xyz for it is different than original xyz. And I can see it here. There is now a new tab under the tree. It's called what? Axis System 1. Now, if I go ahead and create a new point, when I say xyz, these xyz are calculated with respect to what? You see here, they are calculated now with respect to axis system 1. So when I say 1, 1, 1, that's a separate meaning, right? This point here will be like there, right? Correct? So it's a completely different meaning now, this new xyz. So it's going to be here. Well, if I said 1, 1, 2, it would be somewhere like here. Now you might say, what if I now want to create a second point, but the second point I wanted the xyz of that to be with respect to the absolute system, not the new system. How can you do that? Because again, you see, if I want to create a new point, it's with respect to the axis system 1. If we right click here and say clear selection, what happens? It goes back to the original system. So now if I say, as I said, 1, 1, 2, look, it's a separate point. Right? So I use the same xyz, but since my reference was different, the end result is different. Now, you might create a second local system, and let's put the second local system origin at here. And this one, I make xyz of that to be the same as this guy. That's fine. So now I have 3 coordinate frame, and again, if I click on this point, it is going to be with respect to the latest coordinate frame that I have created. So always the latest that I have created will be my new reference for creating any coordinate. But can I change it? So now can I make the system 1 active instead of system 2, or the original one? Yes. So here you see it says system 2. I can right click and say clear selection. If I don't specify, it goes to absolute. But maybe no, I want it with respect to system 1. So I click, and now it is specified with respect to system 1. As I said, if you don't change this, the default is what? The latest system. So each time you want to specify a new point, if you don't want this reference axis 2 anymore, you have to go and change it. Or you can use your default coordinate here. How would you change your default? If you see under axis system, one of them is orange. The rest of them will be black. The orange is the active. If you double click on it, you see it says this is my current or active coordinate. Everything will be measured with respect to this guy. If I turn it off, right, now since none of these is current, when I define a new point, look, it is going to be back with respect to the absolute system. But maybe I want everything to be measured from this point on with respect to frame 1. So I double click on frame 1 and make it what? The current frame. Now from this point on, wherever I click on a point, the default is axis system 1. So by double clicking on any of these guys and making them to be current, you can make that guy the default coordinate frame. If you turn all of them off, all of the new ones, then the original or absolute will be your reference, okay? But as I said, you can always right click here and for the coordinate frame and change it. So if I don't want default, I can click on system 1 and make it with respect to system 1. Okay, so this is the very important topic of creating a secondary or local coordinate frame. Okay. Now that we have seen almost anything that I know myself about surface design in generative shape design workbench, there are two other workbenches I want to briefly talk about them, especially this Freestyle, which is an extensive workbench with so many tools and commands. So I just show you one single command that I really like myself, which uses control points to deform a surface in any shape that you want. And then I also show you a good workbench called Sketch Tracer, which is very good for creating objects that are basically like extrudes. They have a constant cross section, and from the cross section I can get a picture from somewhere, and I want, let's say, to reverse manufacture them. How can I do that? I'll show you. So let's first go over Freestyle, and I show you some stuff about Freestyle. So here, let's say you created a surface in generative shape design, and you want to deform this surface and create a very complicated, let's say, airplane or car surface or anything. Okay, so you have this extrude here from this S-spline, but now you want to do some more change to it. You don't want it like all uniform and all the same across the x-axis. Okay, so you want to create some local deformations, basically. So you learn the command bump, but bump is so limited. You don't have much control over bump. So if you want really more local deformations, then I recommend you go to Start, Shape, and then go to the top one, Freestyle. Here you can literally create surfaces as if you are playing with Play-Doh. So you can hold to some control points and then move them in any direction you want and distort or deform the surface at those locations locally. How? As I said, in this workbench you see a ton of toolbars and commands, and we don't have time, and it's beyond the scope of our course to go over them. But just under this toolbar, the second command from the top says control points. That is my favorite command in this workbench. So if you click on that and then click it on the surface, it creates a bunch of control points. All of these green points are control points on the surface. And then you can move those points normal to the surface, tangent to the surface, and in any direction that you want. So for the moment, let's say I want to move each one of them in a normal direction to the surface at that location and distort it. So let's say I go over that point, you see I get a green line and orange line together. So it means that point is now ready to be selected. So I click on it, hold down left mouse key, and then what? Look, I can move that point in a normal direction to the surface. Then I can come to this point and let's see, move this point normal to the surface. Go to here, move it normal to the surface. Take here, normal to the surface. And then I can do tangent to the surface. So I take this point, move it tangent to the surface. Right? I can take this point and move it tangent to the surface. And then I can move this point normal to the surface, and so on and so forth, right? So now this is the original surface. Let me hide it. And this is what? The modified surface. You see, literally I could do whatever I want to it. I can shape it as I said, like playing with Play-Dohs. You can locally distort it to any shape that you want. You have to be really skillful and know what you're doing. But if you have the skills to form a surface by selecting some points and moving them around, then this Freestyle will give you an unbelievable capability in creating very, very complicated surfaces. Okay, so just wanted you to learn about this workbench Freestyle, and there are a ton of things you can do here. I just showed you one single thing that you can do, which is the main thing actually, control points. But feel free on your own, if you have time, to explore this workbench and learn about it. So that's one thing I wanted you to have some idea about. As I said, this is above and beyond the scope of this course, so I'm not gonna spend a lot of time on it, but I wanted you to learn it. The other one is the sketch tracer workbench, which here again I show you. This does not have a ton of tools. I only have basically a few tools, and I'm going to show you all of those. So as I said, if you have an object from which you have a picture, a profile, you can import that picture into CATIA, trace the boundaries of it, get the sketch, and then extrude it and reverse engineering your part basically, just by having a picture of it. Okay, so you can trace the sketch and insert the picture. And under this link, these are the steps that you have to go through to make this happen. And I'm gonna do them for you here step by step. So let's say you want to create the embroidered eagle object. Okay, so you say EREU eagle. And you get this eagle, right? Then you download this picture. This is really good, by the way, for your reverse engineering project. It can be really useful. So if I get this image as GIF, hopefully it accepts GIF, otherwise we convert it. So we go under Start, Shape, and then we go to Sketch Tracer, right? So this is what you have. And then, as I said, it does not have a ton of tools. It just have a few things, especially these two guys are all it is. And then you click on the one that says Create an Immersive Sketch from Painting Tool. Okay. So this is using screenshots. This is using a general picture. So I click on this one. And then it says, okay, could you get me that picture that you want? And I say, sure, let's see. It does not like GIF, so let me see if I can convert it. Okay, GIF here. So here we open it with Paint. And you can even crop it in Paint a little bit if you want to. So here I cropped it, and then I go under File and then Save it as. And then we'll save it as a JPEG image so that CATIA can read it. And then we go back to CATIA and reinsert it. So here we go to CATIA, click on this again. Now I can get the JPEG image. It says change the shading to shading with material, and also click on the, so if it's not in the front view mode, put it in the front view, and then oh, sorry. And once the axes are appropriate and your shading is shading with material so that you can see the picture, you can further crop the tracing area here if you want to. And whenever you're satisfied and you okay that, now you don't go to Sketch Tracer, and you don't go to Sketcher here. That's a big mistake that you might do, because now you want to trace these boundaries, but you don't go to Sketcher. What you do first is you go to Insert, a new part, and click on this product to get this new part so that it gives you new planes. Now, again, you're not going to select any of these planes and go to Sketcher. What you do, you double click on this part body so that your environment is changed from this workbench to part design, or at least it allows you to modify. So you double click first here, and then if I now choose one of these planes and go to Mechanical Design Sketcher, it should not change this background picture. If you don't do that and then directly from that workbench go to Mechanical Design Sketcher without double clicking on the part first, you would get a blank part, and this picture disappears and you cannot use it. So now you see I could keep this, and now I can zoom in, I can use my splines and lines, and you first turn off snap to the point. Now I can do what? Yes, I can trace this. Now, the important thing is when you are tracing something, if you are reaching to sharp corners where there is no smoothness anymore, so the tangent does change all of a sudden, do not keep using the spline. Splines are smooth curves. When you have this non-smoothness here, at these sharp points, do not use a single spline, but change and go to a new spline. Okay, so you see, whenever I reach a sharp point, I use a different spline. Right, that is very critical. Then again here, like if it's a straight line, you can use a straight line. If it's spline, then go ahead and do another one, and then another one, and another one, and you keep tracing. Make sure the endpoints are all touching each other and you have coincidence. And once you have all of that drawn and it's a closed sketch, now you can basically get out of there, right? And so I'm not going to do all of it, but just let's say you did something and you end up with this closed curve, then you get out. Now if you want, you can go here under this application paint gallery and basically you can hide that picture, and now all that you have is this sketch. Okay, and clearly you can use the sketch under mechanical part design and get what? Get some extrude, right? So this is the method that you use for tracing sketches and creating a replica of a part, which is just a simple extrude and the cross section of it does not change. Okay. Not all parts are like that, so not always you can do this method, but if the parts are simple, extrudes with complicated profiles, this is a very good, extremely good, useful tool. So here, if I show you for the last thing, like one of the files I made myself, if I can find it, it's called Eagle, ERU Eagle cat part here. So here, I use this tool and here we go. Okay. Yes, and I applied gold material to it. So you can easily basically replicate this part.